Hi there, my name is Brandon Groller. I'm a fire engineer with Heartland Fire Rescue in San Diego, California. I've been employed here for 24 years, and today I'd like to talk to you about fire behavior. Right off the bat, the 5 classes of fire are designated in letters A, B, C, D, and K. A is wood, cloth, rubber, plastic, basic combustibles that we see in wildland fires and structure fires quite a bit. Class B is fires from burning liquids and gases such as gasoline or propane. Class C fires are from electrical fires or electrically energized fires, and sometimes we can just unplug something that is potentially on fire, de-energize it, and that takes care of that issue. Class D fires are combustible metals such as titanium, magnesium, zirconium, or aluminum. And finally, Class K fires are the newest one. They're new to fire protection, and they are from cooking oil. To put those out, we use a extinguishing agent that gives saponification, and it turns that cooking oil into soap and therefore extinguishes the fire. To describe fire growth, the fire growth process as it applies to the different types of fuel and classes of fire, we'll look at the 4 stages of fire. The incipient stage or ignition stage of the fire is the initial stage where fuel, heat, and oxygen combine with a chemical chain reaction and a fire is started. The next stage is the growth stage, and this is when the fire gets bigger. It uses the fire load, oxygen, and the size of its surroundings to get larger. The fully developed stage is next, and that's when the fire has reached its maximum and all combustibles have ignited. Finally, the decay stage takes place with the decrease of oxygen and fuel, and eventually the fire decreases and will go out. What are the similarities and differences in pre-mixed and diffusion flames? Both are visible flame and require oxygen. A diffusion flame can be shown by as per the textbook, by a Bunsen burner with the air inlet off. And at that point, the air mixture will take place at the point of combustion, as opposed to the pre-mixed flame where the air inlet on that same Bunsen burner would be on and the mixture would take place prior to combustion, and it is a cleaner, more efficient burning than the initial diffusion flame. Diffusion flames are the common ones we see at fires many of the time, and with structure fires and with wildland fires. Heat of combustion is the quantity of heat evolved by the complete combustion of a specific amount of a substance. It can be measured by an apparatus called an oxygen bomb calorimeter. What it does is it introduces massive amounts of oxygen, and then it measures them, and it is measured from a 0 to a 1. A 0 shows non-efficient combustion, and a 1 represents 100% efficient combustion. Usually the combustion will be somewhere in the middle there. The fire triangle and the fire tetrahedron are similar in that they both contain heat, fire, and oxygen, but the fire tetrahedron also adds a chemical chain reaction that is necessary for the fire to continue to burn. The dangers of smoke come from the products of combustion, such as gases that come from this, like carbon dioxide and carbon monoxide. Smoke also displaces oxygen, and it displaces us with the toxic gases such as those and other toxic gases. Additionally, smoke impedes visibility, which obviously endangers civilians because they can't find their way out of a house, and firefighters, they can't find their way to the fire or inside a house, and makes it tough to fight the fire at all. The difference between the flames with diffusion flames as opposed to pre-mixed flames is the diffusion flames are seen more commonly, and it produces a lot more smoke. The pre-mixed flames are more efficient, and its combustion produces less smoke than the diffusion flames. Thank you very much for your time.